As I was saying, no matter how you position the triangle, all the line segments will be congruent or equal to each other. All the ACs are equal to each other, all the BCs, etc. Now, we next want to find the angle of each one, and so we are going to take our protractor and we can measure each one. So if you drew your triangles, you can do that. But as you can see, I just did it earlier so that we can speed up the process. So again though, if you want to measure, you're looking to put that line at the 0, and then I'm seeing where does this ray go, and this goes to 20, so the angle in between 20 degrees. So for measurement of angle A, we get 130 degrees, measurement of angle B, 20 degrees, and measurement of angle C, 30 degrees. So notice again, just as with the line segments, we notice that AC, AC, AC are all congruent. Same thing with the angles. Angle A is all 130 degrees. No matter how I positioned the triangle, each angle still remains the same. So normally I would have had you each to do your own triangle and then be comparing it with each other and seeing this for yourself. So that's why I drew multiple triangles to show you that however someone interprets drawing it, if they stick to the original information and keeping their segments the same, then the triangle side lengths and angles will end up equal. So that's what our answer to number 4 is. What does it tell us about the triangles? It tells us that they're congruent. Remember, congruent means equal to each other. So write a conjecture or prediction about triangles with 3 pairs of congruent sides. So you can kind of see the point of all this is that if we're given 3 side lengths and we have 2 triangles that have the same side lengths, then those 2 triangles will be equal because we saw that the angles end up being equal too. So this is actually a theorem, and it is called side, side, side. So it's abbreviated SSS, which if you're given two triangles and their corresponding, I'll explain that word soon, and their corresponding sides are congruent, then all the angles are congruent, which then, switching to pen, then the triangles are congruent too. Because if I have the same side lengths and the same angles, the triangles are going to look exactly the same, right? Even if they're maybe just rotated a little bit, everything else will be congruent or equal to each other. Now when I mean corresponding, I mean same position. We kind of talked about this in a couple sections ago when we talked about alternate interior angles or corresponding angles. Like think of that, the corresponding angles we were looking at, in what position are they, and they're in the same position if they're corresponding. So if I were comparing side lengths, I would want to make sure that they're in the same position and then check, are they congruent? So let's continue. Our next way of proving if triangles are congruent is called side angle side, which the name gives you a hint. But again, we're gonna construct a triangle given this information. So first let's measure our line segments. So DE is about 8 centimeters. DF about 4.7, and then let's measure our angle, and it's about 24 degrees. So I suggest you to pause the video and try to draw this triangle on your own. First start with the 24 degrees and then use the idea of the line segments. So I will do that now, but if you want to first pause the video, go for it. Okay, so we're gonna construct triangle DEF. So first what I'm gonna do is just get my 24 degrees. So here, let me put my little vertex there. That looks about accurate. And then I want to draw a line at 24. So constructing this will look something like this. And I know that I'm going to have 8 and 4.7. So I'm going to make this the longer side. So if I extend this to 8, so this is going to be this is going to be DE, so this is 8 centimeters long. And then DF is 4.7. So I want to make sure now that I make 4.7 for DF. So if I now connect F and E, I have completed my triangle. So again, we want to be able to look at all the angles and also see different triangles that were made. So before I constructed 2 triangles and found the angles. And again, just like before, these 2 are congruent no matter how I constructed them. If I was given an angle and 2 sides, that last side will always be the same. So if I measured that last side, I get 4.2, so FE is what I'm looking at. And here I also get 4.2. So constructing that last side gives me a last equivalent side, which makes sense because if I'm using an angle that's the same every time and using 2 sides that are the same every time, then the resulting side has to be the same since the rest is, right? So finding the angle of each one, also I see those are still congruent, they're corresponding, so angle D, my bigger angle are corresponding, and then those are corresponding, and they're congruent. So just like last time, if they're in different positions, that's okay, but all of these triangles, the 3 that I constructed are still congruent because the angles and the corresponding line segments are equivalent. Is it possible to create 2 triangles that are not congruent? So let's say we did have 24 and I made 2 triangles, both having 24 degrees. Well, I can always make ones that aren't congruent because I could make the side lengths different. Or what if I kept the side lengths the same, like 8 and 4.7, but then made the angle bigger? So you can always have things that are the same, but there has to be a certain amount of equivalent things. In this case, we had 2 sides and an angle that are the same, and that makes it enough to be congruent because all that's left then is one side, which has to be congruent, this 4.2, since I basically was forced to construct the other ones based on being congruent. So this theorem is called side angle side, or SAS, which if 2 sides are congruent with an angle in the middle between 2 triangles, then the 2 triangles are congruent. Okay, so let's say we have this triangle, and maybe I'll just draw it a little different like this. So let's say this is 50 degrees, and then this is 10, and this is 12, maybe, just making things up. So I would want to make sure then that corresponding this angle would be congruent, and then this and this would also be congruent. So based on these 2 things, I would know that they're congruent by side angle side. Last one angle, side, angle.
So we're also going to construct a triangle for this one. This one's a bit easier because we have
now just one line segment and then two angles. So measuring GH, we get about 4.9 centimeters. If I measure angle G, spot on 50 degrees. And if I measure angle H, about 28 degrees. So we'll use those to help us to construct our triangle. Remember, the point is that we're constructing multiple triangles, but seeing what happens between them. So if I'm gonna construct, I'm gonna start with GH. So I'm just gonna pick a random place and I'm looking for 4.9 is how long GH is. And then I want to use my protractor to now show the angle. So I know angle G is going to be 50, but I don't